Hello, and welcome to your first video in Pre-Algebra Algebra 1. This is Mrs. Sherfan speaking, and I'll be doing all of your videos for the whole year. At any time, if you have questions during the video and you're watching it in class, please feel free to come up and ask. That would be really helpful for you, especially pausing it, asking, and coming back is a really good strategy here. So as you're watching, please make sure that you've got your audio on, that you're taking good notes, and that you're asking questions. That's really important for this class. So let's go ahead and get started. We're going to start off the year talking about real numbers and the system that we work with. This really is categorizing numbers. I want you to think of it as we're categorizing numbers. And the example I'm going to sort of use with this flow chart is thinking about it sort of like a clothes closet. I know that sounds kind of strange, but if we think about a clothes closet, I can say that my closet has clothes. But that's not super specific. I could say my closet has 10 pairs of pants, 3 dresses, 4 sweaters, 2 t-shirts, and put them into categories like that, mostly so I can organize my closet, right? So we can think of numbers in the same way. So this flow chart is meant to help you see how those numbers are categorized. I'm going to come back to this flow chart in a little bit, but I want it to be the first thing you see, so when you come back to it later, you have this as a nice visual graphic. Okay, so let's go ahead down to our notes of our examples for these types of numbers. So the first set of numbers we're going to talk about are natural numbers. You'll notice that natural numbers are here at the very bottom of the flow chart, because those are sort of the first numbers we ever work with, especially as small children. The first numbers I know that my kids start saying start with 1. That's the same thing with natural numbers. We can call these numbers counting numbers. And with counting numbers, we don't start off counting with 0. We start off counting with 1. So counting numbers start with 1. Okay, so examples of these types of numbers, and I'm going to use a special type of notation called set notation. It kind of looks like a little curly bracket. I'll make that a little nicer. It's a little curly bracket. And this is set of notation. This is called set notation. So whenever you see this, you can think of set of. And these numbers start with 1, then 2, then 3, then 4, and then we can go further into 5, 6, 7, and into infinity. The important key part here is that natural numbers start with 1. There are no numbers before 1 that are included in this set. So those are your natural numbers, okay? Now, natural numbers are also included in the set of whole numbers. So the whole numbers are all of our counting numbers. So it's still all of your counting numbers, that 1, 2, 3, 4, etc. But now we're going to include the number 0. Okay, so that also falls here at the bottom of the chart. So we're including 0 into our whole numbers. So when we talk about what those examples look like, I'm still going to use that set notation because it's showing like the set of all the numbers that we're working with here. But now I'm going to start off with 0 and then 1, 2, 3, 4, etc. Okay, so the key here is that it includes 0. Okay. The next set of numbers we're going to work with are integers. And let's actually take a look at our flow chart here. Okay. So integers, okay. Integers are whole numbers, but they also include negatives. Okay. So integers are all the whole numbers, and they're also negative whole numbers. So let's put that in our definition. So we're going to have the counting numbers, the whole numbers, and we're going to include negatives. Okay, so we're going to do 0, 1, 2, 3, but we also want to make sure we've got those negative 1, 2, 3. So the way we're going to write this in set notation is we're going to have dot, 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 and I'm going to start with -3, -2, -1, 0, and these are just some examples, and it goes on forever to positive infinity and to negative infinity. So, for example, -49 is considered an integer. The number 10 is considered an integer. 0 is considered an integer. So it includes all of the sets before it. Okay, so counting, natural numbers, whole numbers, and negatives are all included in the set of integers. What color did I use for integers? I think I used blue. I did use blue. So integers are, I'm going to make mistakes like this several times in videos, so just lean into that. Okay, so integers, there we go. The next set of numbers that we can lump everything into are rational numbers. This might be a new word you haven't heard before, that's okay. Rational numbers are a big set of numbers. Rational numbers are going to include your counting numbers, so 1, 2, 3, etc. It's going to include whole numbers like 0. It's going to include those integers that are your negative whole numbers and counting numbers. And it's going to include fractions now. And this is really important. It's going to include decimals, but a very specific type of decimals. Decimals that stop or repeat. Okay, so that's included here, rational numbers. And if we go up to our flow chart, notice that rational numbers include our fractions, include our integers, and they also include those decimals that stop or repeat. So what are some examples of those? So some examples of those would be, let's say we can come up with a bunch. I can just make these up. Let's say 5/7. That's a fraction. So an integer over an integer is considered a fraction. So 5/7. The number 3. 3 is a counting number. It's a whole number. It's an integer, and we can also call it rational. The number -1. That's an integer, and we can also call that rational. 0 is also included because it's included in the whole set of numbers. And then we start getting into these decimals. So something like 2.5, that decimal stops. It's not saying 2.51789 and goes on forever. It's just 2.5 stop. So that's considered rational. But what if we also have something like 1.7 repeating? This little symbol up here means repeating. So you might see that coming up throughout the year. That little bar above the number means it's going to be basically 1.7777 and forever. You might also see a repeating decimal look like this, 3.252525 ... And you need to assume that that means that 2525, that will repeat as 2525. So this is a repeating decimal. These are all examples of rational numbers. Rational numbers include a ton of numbers. Okay, they include a lot. It's almost like saying this is my closet. This includes all of my shirts, my pants, my dresses, etc. Includes a lot of things. Then we've got this last set of numbers. And this last set of numbers we call irrational. Irrational numbers are very special. They don't include any of the other categories we've just talked about. In fact, if we go back up to our flow chart, we can see that they're in their own separate category with nothing underneath it. Okay, they're unique. So irrational numbers, let me get my pen back. So irrational numbers are only numbers that are decimals, that do not stop. We can say never. They never stop or repeat. They go on forever. With no pattern. So here's some examples of that. And if you have a graphing calculator, You might want to get that out. If not, just take a look at what I'm about to show you so you can see how you can figure out what kind of decimal you're working with. I'll tell you a couple examples that you don't need your calculator for. One example would be something like 1.29357 ... You can see there's nothing repeating here. The 2, 9, 3, 5, 7, they're random numbers. The ... means it's going to go on forever, but there's no pattern here. It's not like the 2, 5, 2, 5, 2, 5. This would be considered irrational. Another number considered irrational is something like the square root of 3. We're going to be seeing a lot of square roots in this year. And one way you can actually tell what kind of decimal that is, because the square root of 3 could potentially be like a whole number, right? Like the square root of 9. The square root of 9 is 3, and that's a whole number. That's an integer. That's a rational number. So that wouldn't be considered irrational. But the square root of 3, if we go to our calculator and we hit the blue button here, and then we hit the x squared button, you'll see that a little radical pops up. I can type in the number 3 and hit enter, and notice what kind of decimal am I getting here. I'm getting 1.732, a number that doesn't repeat, doesn't stop, it goes on forever in a random pattern. So the square root of 3 is considered irrational by our definition. So the square root of 3 is going to be an irrational number. Another great example of an irrational number is something like pi. Pi is typically 3.14 for a lot of math you've had. You just say 3.14. But really pi, if we type that into the calculator, that is a decimal that's going to repeat a decimal that won't repeat, won't stop. So if I go and hit the blue button again and hit the little tilde up, that's going to put pi into my calculator. If I hit enter, I get a similar type of decimal in my calculator. I get 3.14159, etc. It doesn't stop, doesn't repeat, so that's an example of an irrational number. Okay, so those are all the ways we're going to categorize numbers. And so here's what I'd like you to be able to do with this skill and with this information. I'd like you to be able to look at numbers and say what category they fall into. So I've got some examples of numbers here, and we're going to talk about what category they fall into. So for example, A has the number 4. So 4, can we count? Was 4 a counting number? Sure, 1, 2, 3, 4. So that's going to be considered natural. And you can circle these or underline these, whatever works for you. So natural numbers. Natural, it's also a whole number, okay, because 4 falls into the set of naturals, and whole numbers include naturals. It's also an integer. Okay, it's a number I can count to, a number that's not a decimal, and it's positive, and that's okay. That's included in the integer set. And it's also considered rational because we can technically write 4 as 4 over 1. We can put anything over 1 and turn it into a fraction. Okay, so these categories are all the ones that we can put the number 4 into. We can't put it into the irrational category. Okay, it doesn't fit into the irrational category. You can cross it off if you like, but it doesn't fit into irrational. It's not a decimal that's not a decimal that goes on forever and doesn't repeat, doesn't stop. 0.7, the number 0.7, that's not natural. We don't count to 0.7. It's not whole. It's a decimal. It's not an integer because it's a decimal, but because it's a decimal that stops, this is a decimal that stops, we're going to consider that rational. Because it stops, it's not irrational. A number can only be rational or irrational. It cannot be both. So if something's irrational, it can't be rational. If it's rational, it can't be irrational. How about negative 23? Negative 23 is not natural. We don't count to it. It's not a whole number because it's negative, but it is 23 is not a decimal, so we can consider it an integer because it doesn't have a decimal in it, and since it's negative, we can call that an integer. Integers are also rational. All integers are considered rational numbers, so it fits into these two categories. It doesn't fit into irrational, it doesn't fit into whole, it doesn't fit into natural. We could also cross these off for this last example as well. Okay, how about negative 6/5? Negative 6 over 5, we don't count to it. It is a fraction, so it can't be whole. Again, it's a fraction, can't be an integer. But since it's a fraction, we can consider that a rational number. Okay. 6/5 is a fraction. That's going to be rational. Square root of 13. I need to first check to see the square root of 13 what kind of decimal it is if I'm not sure. So I'm going to go back to my calculator. I'm going to hit the blue button and I'm going to hit the x squared button to pop up my radical. Then I'm going to type in 13. When I hit enter, I get 3.65055. So this is a decimal that doesn't repeat, doesn't stop. So I can call this number irrational. That means it's not rational, it's not an integer, it's not whole, it's not natural. Okay. How about 2.57? It has the bar above it, so make a note that this does repeat. A repeating decimal is considered a rational number. It's not irrational, it's not an integer, not whole, not natural. It doesn't fit in any other category but rationals. Pi, we just talked about pi, right? We just said that pi is going to be a number that's irrational because if we put it into our calculator and we understand that pi is not a number that stops, it's not a number that repeats, it's going to fit into the irrational category. It doesn't fit into any other place. And the number 0 can be tricky. The number 0 fits into the whole set, but it doesn't fit into our natural set. We don't start off by counting with 0. We start off counting with 1. That's the natural set, starts with 1. It's not included in the natural set. It is included in whole. Because it's a whole number, that's also considered an integer, and because it's a whole number, it's also considered rational. It fits into all three of those categories. Does not fit into irrational. It's not a decimal of any kind. So this is sort of the skill I want you to have here in this lesson. I want you to be able to look at a number and categorize it and also understand what different categories they fall into in this flowchart. So I'm going to go back up to this flowchart to end the lesson. Being able to understand that all real numbers are the numbers we're working with this semester, and we have ways that we can sort them. Okay. Your next step now is to do the practice. So when you look in your spiral, you're going to see that you have practice after the lesson. So you can close your laptop, come back to your desk. If you're not already at your desk, put your laptop away and go ahead and start that practice. If you have any questions at all, please come speak with me. I'll be happy to help in any way I can. That's the whole point of this type of class, is that you get the help that you need to learn the material. So good luck, and I'll talk to you soon.